Welcome to another present here, and I warmly welcome our respected faculty members and my dear friends. Today, I will be presenting on the topic of aerospace application and composites, which is a part of Unit 5 Aircraft Composites and Additive Manufacturing under the course Aircraft Manufacturing Technology. Before we begin, I would like to thank my department and faculty members for giving me this opportunity to present on this topic. So, first of all, let's we recall. So, aerospace applications of composite and the key advantages it is lightweight with the fuel efficiency and high strength to the required weight. And when we compare about the major applications, it is a commercial aircraft wings and for fuelage and aircraft and rockets. And we compare to the primary challenges. It is high cost and also complex and repair inspections to be done. So, aerospace applications of composites. What essential advantages makes a CFRP to choose the primary aircraft parts is to and the whereas essential aerospace components use besides commercial planes. These will be seen on the following topics. And today's topic for discussion. In today's session, we will be briefly explore four major areas. One is the core advantages of composites, which is especially their lightweight strength, and CFRP and its dominance, where in the modern aircraft structures. And the third one is applications beyond commercial aviation, that including space and defense. And the final is the future challenges and the next generation improvements in the composite materials. This flow helps us to understand how material properties translate into real world aerospace performance. And let's explore what the things which we are going to see is the slide explains us that the direct link between the composite properties and the operational results. For example, carbon fiber reinforced polymer uh, offers a high strength and low weight. This directly improves the fuel efficiency, payload capacity, and flight range. So the material science behind the composites becomes an in, intimate advantage for airline operators and aircraft designers. And the composites, what we are going to use, or we see how composite materials are used in the differently across aerospace fields. So 60% of the use is focused on the cost and efficiency, mainly in commercial aircraft, and 30% of self uh, survivability and performance, especially in military aircraft like fighter jets. And the balance 10% is for extremely conditions such as rocket launch vehicles and spacecraft, where the temperature and the pressure conditions are extremely harsh. And the challenges and the evolution. Although the composites offer a great advantage, they also comes with the challenges. Production costs are high, especially for aerospace grade CFRP. Manufacturing requires precision, such as autoclave, curing, and layered lamination. Inspection is difficult because it damages may be internal and visible from the outside. However, with automation, robotic fiber placement, and resin transfer modeling, these challenges are gradually being overcome. And the applications of the composites in the real world. The composites are extensively used in aircraft wings, fuselage sections, and control surfaces, helicopter robot blades, satellite structures, unmanned aerial vehicles, rocket motor cravels. For example, the Boeing 787 Dreamliner uses nearly 50% of the composite by weight, making it one of the most fuel efficient commercial aircraft in the world. So, with this, when we go to the main work, this slide summarizes the entire concept visually. Composite integrate strength, lightweight, construction, corrosion resistance, fatigue durability, and design flexibility, which ultimately leads to better aircraft performance and low maintenance. So, When we take about the aircraft composite material, it can be defined as a superior properties impact on the industry and engineering combinations. The key applications of the aerospace composite materials uh, can be explained by the airframe structures which it uses and the propulsion system which it ignites and the landing gear and the interiors with the aircraft and emerging uses. So when we come for the benefits of the aerospace components materials, it is one of the best fuel efficiency and the durability and the design freedom. So what are the challenges when we see with the incorporate of the aerospace composite materials are the costs and manufacturing methodology, the damage sustainability and the logical hurdles. Mm. And what will be the curiosity challenge in the upcoming years? And we will be saying that an interesting point in the metal wings, scratches or cracks are clearly visible, making the inspection easier. But in composite wings, cracks may be internal and visible. This means composite inspection requires advanced non-destructive testing like ultrasonic scanning or thermography. This is one of the main challenges in the maintenance. So when we come to the assessment part, so the question is, what is the primary structural advantage of CFRP composites over the aluminum in aircraft? The options are lower material, high electricity conductivity, superior strength weight to ratio, and others. And the second question is, what is the main structural challenges when inspecting a composite material as compared to a metal weight? So when we see, it gives us an option C for the first question, that is superior strength weight to the ratio. And for the second question, it is invisible internal damage. So these answers reinforce the key learning points from the presentation. Mm, So the reference. This slide lists the source of references used to prepare the content, including the research articles and the aerospace components. Mhm. Thank you for listening my presentation. I hope this session is helped you to understand the importance of composite materials in the aerospace industry. Thank you all.